Here's your video for solving absolute value inequalities. When it comes to solving absolute value inequalities, we have to be aware of two separate situations that we will encounter. These situations are, one, when the absolute value of x is greater than some number, and the other when the absolute value of x is less than some number. Let's first look at these ideas on a number line. So an inequality that is referring to an absolute value greater than c, let's think of absolute value as distance from 0. So it means to the right there is some number c, and we want numbers that are further away from 0. So if I'm doing some shading about where these numbers might be, absolute value or distance from 0 greater than c tells me go beyond c is where I want to have my shading. Now this is a strict inequality. It's greater than, but not equals to. So on the graph, either we'll use an open circle, or we use a round parentheses. And these days I see more often a round parenthesis used, so we'll use those instead of the open circle or closed circle when we do have an equals part to the inequality. So that's the right side, our distance from 0 greater than c, but what does it mean for the left side? It means that there is a number negative c, and we are interested in numbers that are further away from 0 than that. So beyond negative c, even more negative numbers, and going all the way to the left on the number line. So when we see an absolute value greater than a number, we're thinking about it leading to two separate intervals on the number line. One is coming from x greater than c. The other interval is from x is less than negative c. And as we solve absolute value inequalities, this is how we'll handle them. We'll split them up into two separate inequalities. Just like we would split up absolute value equations into two equations, the inequalities we're going to split up into two inequalities. Let's also talk about using interval notation as an alternative to writing an inequality. So if we think of this shaded interval on the number line, which goes from c up through the increasing numbers, larger numbers, I would have an interval right here that goes from c to positive infinity and continues forever to the right, and this other interval on the left goes from negative infinity to negative c. We always write our intervals from left to right with the smaller number and then the larger number. This shaded interval goes from negative infinity as far left as possible on the number line, and the shaded area continues to negative c and then it stops. And then our other interval begins at c and continues to the right. And we join these two with the union symbol. So this type of absolute value inequality, a greater than, leads to two intervals. So we would have two inequalities for our solution, either or. And in interval notation, we would need to write both intervals with the union symbol. What would this inequality mean? Absolute value of x is less than c, so there's some number on the number line c, but we are interested in numbers whose distance from 0 is less than c, numbers that are closer to 0. So if I'm shading an area in between 0 and c. And again, we have a strict inequality, a less than with no equals part, so I'm using a round parenthesis. And what happens to the left, there's another number, negative c, and we want a distance from 0 that is less than that distance c. So we're shading closer to 0. Now this inequality, true, it is still two inequalities that have been split up because that's how we handle absolute value, but in this case, a couple of details to know. First of all, those two inequalities that we would set up, x greater than negative c, and x less than c, these two are joined with an and to say that we're looking for x values that work for both cases. And this really is all tied to this idea that we're looking for numbers whose distance from 0 is less than c. So they're much closer to 0. They're in between positive and negative c. Different from this absolute value greater than c when we're saying go further away from 0 than c or negative c. Now what we can do with any inequalities that are joined with an and is try to make a compound inequality. And I actually still think about what I see on the number line here. I have x represented by this shaded area. It's greater than negative c but less than c. So that's how my compound inequality is written, with the x right in the middle, negative c on the left, and positive c on the right. My x would be numbers right in between them, and I'm cautious with my inequality symbols so that I'm really showing that x is less than the positive c, but greater than the negative c. And when it comes to interval notation, I see that on the number line, it was not two intervals, it was just one interval. So in interval notation, I only need one interval between negative c and positive c. When I look from left to right, I see my shaded area begin at negative c and end at positive c. So that's the basic info that we need to know when it comes to solving absolute value inequalities. We have to decide which type of inequality are we looking at. If it's an absolute value greater than, then we're thinking about two intervals where we're going further away from 0 than c. And absolute value less than c, we're thinking about just one interval right around 0 that is wedged in between negative c and positive c. So we can talk about all these numbers whose distance from 0 is less than c. They are closer to 0 than c. At this time, let's also cover what happens if we don't have strict inequalities. Here, absolute value greater than or equal to c, and over here, less than or equal to c. It's not going to make any huge changes. In terms of the number line, instead of using round parentheses, we use square brackets. When we split up the inequalities down here, we still have to use these non-strict inequalities. So if it begins with an equal sign, we will use inequalities that have an equals part down here. And our interval notation, just like the number line, should use square brackets instead of round parentheses. And just a point of information, at the negative infinity and positive infinity, we always use round parentheses there. On this side, for numbers that are closer to 0, if it had this equals part, again, we'd see our graph would use square brackets instead of round parentheses. When we split up the inequality, we would use inequality symbols that have the equals part, even when we have it in this compound inequality form. And in our interval notation, again, square brackets, not round parentheses. Let's cover a couple of basic examples first. Absolute value of x greater than or equal to 3. So think about on the number line, are we looking at shaded areas, two shaded areas that are far away from 0, or one shaded area that is close to 0? Well, absolute value, so our distance from 0 is greater than 3. It's more than 3. So a distance that is further out than 3. On the number line, 0 right in the middle, here's 3, positive 3 out to the right, and we are interested in numbers that are further away from 0. And on the left, numbers that are further out than negative 3. So there are those numbers whose distance from 0 is more than 3. And we have the square brackets to say more than or equal to 3. Now, since we see two intervals, we know we need two inequalities. On the right, this one is from x is greater than or equal to 3. And this interval on the left is from x is less than or equal to negative 3. There are our two inequalities in the solution. Here's our graph. And let's lastly do the interval notation. So one interval goes from negative infinity to negative 3, and we use a square bracket this time because we have an equals, a non-strict inequality, and this interval that picks up at positive 3 also uses the square bracket. Let's look at this other example. Absolute value of x is less than 2. So numbers whose distance from 0 is less than 2. They're closer to 0 than positive 2. So to the right, if I think about going out to positive 2, I have to stay closer to 0. And to the left, I see negative 2, but my shaded area is closer to 0. Our distance from 0 is less than 2. So we are close to 0. Now I only see one interval. I'm thinking use a compound inequality. X in the middle with greater than negative 2 and also less than positive 2. And in interval notation, just one interval from negative 2 to positive 2. and round parentheses because of this strict inequality, no equals part. Here's our next example. Absolute value of 2x minus 3 is greater than 1. We should still start out by thinking, is this a problem with two intervals that are farther from 0 or one interval that is close to 0? Well, remember, absolute value, distance from 0, greater than 1. So we're looking for distance greater than 1. We're looking for two separate intervals. We're looking at 2x minus 3 is greater than 1, or 2x minus 3 is less than negative 1. And that's how we're getting those two intervals, greater than positive 1, so to the right of positive 1, and here to the left of negative 1, so less than negative 1. At this point, it's just solving these linear inequalities. We're working to get the x on one side, number to the other sides. We're doing some moves to both sides of the inequality. Add 3, and then we'll divide by 2, leads us to x is less than 1, or x is greater than 2. Let's write our answers in interval notation. Two separate inequalities, so we need two separate intervals. The first one, x is less than 1. So we're going from negative infinity up to positive 1. And the other interval, x is greater than 2, we begin at 2 and increase towards positive infinity. And let's take a quick look at these intervals on a number line. One interval coming from this inequality, x is less than 1, so I have a round parenthesis shaded to the left for the less than. And over here, x is greater than 2, round parenthesis at 2 and shading to the right. Let's look at another example. Let's actually look at this example, but if we were using a less than inequality instead of a greater than. Absolute value of 2x minus 3 is less than 1. So our distance from 0 is less than 1. We're looking at an interval that is close to 0, and it's just one interval. So we can set up a compound inequality. 2x minus 3 has to be between negative 1 and positive 1. That's how we're saying our distance from 0 is less than 1. It can't go farther to the right than 1. It cannot go farther to the left than negative 1. Now, how do we solve this compound inequality? What we're working to do is solve for x just with this expression in the middle. So I'm thinking about, what do I need to remove to get this x by itself? I see a minus 3, I'm doing a plus 3, and whatever we do to the middle, we have to do onto each end. So everything added 3 leads me to this compound inequality, and my next move would be to solve for x, divide by 2 everywhere, leaves me with x is in between 1 and 2. It is greater than 1 and less than 2. In interval notation, we know this sort of absolute value inequality leaves us with just one shaded interval. It is between positive 1 and positive 2. A quick look on the number line there, we're shading in between 1 and 2. So we've described some steps that will pretty accurately set us up to solve these absolute value inequalities, but there are still some basic facts that we should not forget about. Think about this inequality. Absolute value of 8x minus 7 is greater than or equal to 0. Well, ignore the actual 8x minus 7 in there and think about what this is saying in terms of distance from 0. Our distance from 0 is more than or equal to 0. Well, can you imagine where on the number line we would see points where their distance from 0 is either 0 or greater than? Basically, all real numbers. So be cautious when we get to absolute value equations or inequalities that use zeros, and also when we see them with negative numbers, because we should apply these fundamental ideas to solve those. An absolute value greater than or equal to 0, well, that happens all the time. That's how we define what absolute value does, that it makes everything positive, which is greater than or equal to 0. And how about this one? Absolute value of 4x plus 9 is less than negative 2. So think about this without the 4x plus 9. A distance from 0 is less than negative 2. And we say that absolute value, since it is distance, is always a positive result. So I could never get a number that is smaller than negative 2, because that leaves me with only options that are negative numbers. An absolute value can only be positive. So this inequality will have no solution. Here's a good example for you to try. So pause the video and work this one out and then restart. We'll look at the answer together. With this inequality, I have to see it's less than or equal to 12. Distance from 0 is less than 12, so this is the type where I have just one interval where distance from 0 is less than 12, so an interval that is between negative 12 and positive 12. The 5x plus 3 is greater than or equal to negative 12 and less than or equal to positive 12. We'll solve by move 3 out from each of these sides, subtract 3, and then next we will divide everything by 5. And there is our solution, that x is numbers that are greater than or equal to negative 3 and also less than or equal to 9/5. Let's graph this solution on the number line. So I need to pick out negative 3 and positive 9/5, and x is between them. So I'm shading in between those two numbers and using square brackets because we do not have strict inequality. We have the equals part to those inequalities. And what will the answer look like in interval notation? There's our one interval. The shading begins at negative 3 and ends at 9/5, and square brackets on the interval notation. Let's do one last example. Absolute value of 3x plus 1 over 2 minus 4 is greater than 0. Now when we have our initial thoughts about, is this the type of problem that is setting us up for two intervals going farther away from 0, or is it setting us up for one interval very close to 0? Before we do that, we need to make sure that our absolute value part is isolated. So this minus 4, I want to move that over to the right side with an add 4 to both sides. Now my absolute value part is isolated, and now I can proceed with this problem as we have with the last few examples. Absolute value of 3x plus 1 over 2 is isolated. We're saying it's greater than 4. So now, is this setting us up with two intervals or one interval? And we should see two intervals. One interval going farther to the right, farther than 4, and the other interval going farther to the left, farther than negative 4. So I'm splitting this up into two inequalities. 3x plus 1 over 2 is greater than 4, and 3x plus 1 over 2 is less than negative 4. Farther to the right than positive 4, farther to the left than negative 4. And now to solve, I always like to clear the fractions out first if I can. So it will be multiply both sides by 2, takes me to these two inequalities, and then solving with moves on both sides. X is greater than 7/3, or x is less than negative 3, and it's or because we have two separate intervals. Let's look at the graph on the number line. 7/3 and shading to the right and around parentheses because of this strict inequality, and round parenthesis at negative 3 and shading to the left. In interval notation, we have two intervals, so we need to write two intervals in interval notation. This first one, shading begins all the way on the left, negative infinity, and goes to negative 3, and union that interval with this next one that goes from 7/3 and continues to the right towards positive infinity.